In the late summer of 1977, a radio telescope in Ohio picked up a signal so powerful and so unusual that the astronomer who discovered it scrawled, "Wow." In the margin of the printout, decades later, the so-called WOW signal remains one of the most tantalizing mysteries in the cosmos, a fleeting burst of energy that defies explanation. And it's just one of countless enigmas scattered across the vast expanse of space, from celestial objects that shouldn't exist to forces that seem to break the very laws of physics. The universe is brimming with phenomena that leave even the brightest minds scratching their heads. Today, we're diving into 25 of the most unusual and perplexing mysteries in space phenomena that challenge everything we think we know about the cosmos. Whether you're a seasoned space enthusiast or just someone who loves a good mystery, this journey will take you to the edge of understanding and beyond. Ready to explore the unexplainable? Let's begin. Picture this. It's a quiet August night in 1977, and a massive radio telescope in Ohio is scanning the skies for signals from the cosmos. Suddenly, it picks up something extraordinary, a burst of radio waves so intense and so unusual that it stands out like a beacon in the darkness. The signal lasts for 72 seconds, and when astronomer Jerry Amon reviews the data, he's so stunned that he circles the reading on the printout and writes a single word beside it: "Wow." This brief, mysterious burst of energy would go down in history as the WOW signal, a cosmic enigma that still baffles scientists to this day. What makes the WOW signal so puzzling? For starters, it was incredibly strong, about 30 times louder than the usual background noise of space. It also came from a specific region in the constellation Sagittarius, a part of the sky rich with stars but devoid of any known natural sources that could explain such a powerful signal. And then, just as quickly as it appeared, it vanished. Despite decades of searching, no one has ever detected it again. So, what could it have been? Some speculate it might have been a message from an extraterrestrial civilization, a fleeting attempt to reach out across the vastness of space. Others argue it could have been a natural phenomenon, like a comet or a distant star emitting an unusually strong burst of energy. But none of these explanations fully account for the signal's unique characteristics, leaving it as one of the most tantalizing unsolved mysteries in astronomy. The WOW signal isn't just a curiosity, it's a reminder of how much we still have to learn about the universe. It's a humbling glimpse into the unknown, a brief moment where the cosmos seemed to whisper something we couldn't quite understand. And while we may never know its true origin, it continues to inspire the search for answers, driving scientists to scan the skies for other unexplained signals. Speaking of which, the universe has no shortage of strange sounds and signals that defy explanation. Now, let's shift our gaze to another cosmic mystery that has left astronomers utterly perplexed: fast radio bursts, or FRB. These are incredibly brief bursts of radio waves lasting just milliseconds, but don't let their short duration fool you. In that fleeting moment, an FRB can unleash as much energy as the sun produces over days. Imagine the power packed into such a tiny blip in time. It's as if the universe is sending us a cryptic message, one we're still struggling to decode. The first FRB was detected in 2007, and since then, hundreds more have been recorded. What makes them so baffling is their unpredictability. Some FRBs are one-off events, appearing once and never repeating. Others, like the infamous FRB 121102, have been caught flaring up multiple times, giving scientists rare opportunities to study them. But even with these repeat offenders, the question remains: what could possibly generate such an immense burst of energy in such a short time? One leading theory points to neutron stars, the dense remnants of exploded stars. Specifically, a type of highly magnetized neutron star called a magnetar is thought to be a prime suspect. Magnetars are known for their intense magnetic fields, which could potentially produce these explosive bursts of radio waves. Another possibility is that FRBs are the result of cataclysmic cosmic events, like black holes colliding or neutron stars merging, releasing torrents of energy in the process. But here's where things get even more intriguing. Some have wondered if FRBs could be evidence of advanced alien technology. Could these bursts be signals from a distant civilization, perhaps even a form of interstellar communication or propulsion? While this idea is speculative, it's not entirely outside the realm of possibility. After all, the universe is vast, and we've only just begun to scratch the surface of what might be out there. What's clear is that FRBs are more than just a scientific curiosity. They're a puzzle that challenges our understanding of the cosmos. Each burst we detect brings us a little closer to unraveling their origins, but for now, they remain one of the most enigmatic phenomena in the universe. And as we continue to search for answers, they remind us just how much there is to discover. But fast radio bursts aren't the only strange things lurking in the depths of space. What about the bizarre objects orbiting distant stars, defying our expectations and raising even more questions? Let's take a closer look at those next. Now, let's turn our attention to a star that has captured the fascination of astronomers and science enthusiasts alike. Tabby's star, officially known as KIC 8462852. This star, located about 1,400 light-years away in the constellation Cygnus, has become famous for its bizarre and unpredictable dimming patterns. Unlike most stars, which dim in regular, predictable ways due to orbiting planets or natural cycles, Tabby's star dims erratically, sometimes losing up to 22% of its brightness at once. To put that into perspective, even a giant planet like Jupiter would only block about 1% of a star's light. So, what could possibly be causing such dramatic and irregular changes? When Tabby's star was first observed by the Kepler Space Telescope, its strange behavior immediately stood out. The dips in brightness didn't follow any recognizable pattern, and they were far too extreme to be explained by typical stellar phenomena. This led to a flurry of theories ranging from the plausible to the downright speculative. One of the most tantalizing ideas was that the dimming could be caused by an alien megastructure, a gigantic construction like a Dyson sphere designed to harness energy from the star. While this concept captured the public's imagination, scientists have since proposed more grounded explanations, such as massive swarms of comets, interstellar dust clouds, or even remnants of a shattered planet orbiting the star. Despite years of study, the mystery of Tabby's star remains unsolved. Researchers have ruled out some possibilities, like the alien megastructure theory, but others remain on the table. What makes this star so fascinating is that it challenges our understanding of how stars and their surrounding environments behave. It's a reminder that even the most familiar objects in the cosmos can still surprise us, and that there's so much we have yet to learn. Tabby's star isn't alone in its strangeness either. Across the galaxy, astronomers have discovered other stars with peculiar characteristics that defy easy explanation. For example, there's EPIC 249706684, a star that dims by an astonishing 80%, or Vega, which has a mysterious disk of debris surrounding it. Each of these stars adds another layer to the growing tapestry of cosmic enigmas, pushing us to rethink what we know about the universe. As we continue to study these puzzling stars, they serve as a testament to the boundless complexity of the cosmos. They remind us that even in the vastness of space, there are still questions waiting to be answered, and perhaps discoveries waiting to be made. And speaking of discoveries, let's venture into another corner of the universe where the rules of physics seem to bend in ways that leave scientists utterly baffled. And now, let's turn our attention to a mystery that has sparked both scientific curiosity and wild speculation for decades: the so-called Black Knight satellite. This enigmatic object, said to be orbiting Earth, has become the subject of countless conspiracy theories, with some claiming it's an ancient alien artifact, while others argue it's simply a piece of space debris. So, what's the truth behind this elusive satellite, and why does it continue to captivate imaginations around the world? The story of the Black Knight dates back to the late 1950s, when amateur radio operators reportedly picked up strange signals from an unknown object in orbit. These claims were later fueled by images captured during early space missions, which appeared to show a dark, irregular object hovering above Earth. The most famous of these photos was taken during the Gemini missions in the 1960s, and it's this image that has become the centerpiece of the Black Knight legend. But is there more to this story than meets the eye? For many, the idea of an ancient satellite orbiting Earth is irresistible. Some theorists suggest the Black Knight could be a relic of an advanced extraterrestrial civilization, left behind to monitor humanity or even guide our development. Others propose it might be the remains of a lost human civilization that achieved spaceflight long before modern history. These theories are undeniably intriguing, but what does the science say? Skeptics argue that the Black Knight is likely nothing more than a piece of space debris, perhaps a thermal blanket or other discarded material from a spacecraft. After all, Earth's orbit is cluttered with thousands of man-made objects, many of which can appear mysterious or out of place when viewed from a distance. Even the famous Gemini photo has been debunked by experts, who attribute it to a combination of camera artifacts and the play of light and shadow. Yet, despite these explanations, the allure of the Black Knight persists. What makes this phenomenon so fascinating is the way it blurs the line between science and speculation. It's a reminder of how easily our imaginations can take flight when confronted with the unknown. Whether the Black Knight is a piece of space junk or something far more extraordinary, it serves as a symbol of humanity's enduring fascination with the mysteries of the cosmos. And as we continue to explore the skies, who knows what other secrets might be waiting to be uncovered? But the Black Knight isn't the only mysterious object capturing our attention. Closer to home, within our own solar system, there are other enigmas that defy explanation. Let's take a closer look at one of the strangest, a peculiar object that has astronomers scratching their heads and rethinking what we thought we knew about our cosmic neighborhood. In October 2017, astronomers made an extraordinary discovery, a mysterious object hurtling through our solar system at breakneck speed. Named Oumuamua, a Hawaiian word meaning scout or messenger from afar, this interstellar visitor was unlike anything we'd ever seen before. Measuring roughly 400 meters long but only about 40 meters wide, Oumuamua had an elongated, cigar-like shape that defied all expectations. Most natural space objects like comets or asteroids are irregular but roughly spherical. Not this one. Its unusual form was just the beginning of the mystery. What truly baffled scientists, though, was the way Oumuamua moved. As it passed through our solar system, it didn't follow the predictable trajectory of a typical comet or asteroid. Instead, it sped up as if something were pushing it forward. This unexpected acceleration couldn't be explained by gravity alone, and it left astronomers scrambling for answers. Was it venting gas like a comet? If so, why didn't telescopes detect the telltale signs of a cometary tail? Or could there be another, more exotic explanation? One of the most intriguing theories suggested that Oumuamua might be a piece of alien technology, a probe or even a fragment of a spacecraft sent by an extraterrestrial civilization. This idea, proposed by Harvard astrophysicist Avi Loeb, sparked both excitement and skepticism in the scientific community. Loeb argued that the object's unusual acceleration and shape could be evidence of a light sail, a device designed to harness the pressure of starlight for propulsion. While this theory remains controversial, it's a fascinating possibility that highlights just how little we understand about interstellar objects. On the other hand, many scientists lean toward more natural explanations. Some suggest Oumuamua could be a rare type of comet, one that doesn't produce the typical cloud of gas and dust we associate with cometary activity. Others propose it might be a fragment of a larger object, torn apart by a cosmic collision or the gravitational forces of its home star. But even these theories struggle to fully explain the object's peculiar characteristics, leaving Oumuamua as one of the most perplexing enigmas in modern astronomy. What makes this interstellar visitor so compelling is that it's a reminder of how much we still have to learn about the universe beyond our solar system. Oumuamua is the first confirmed interstellar object ever detected, and its brief visit has opened up a whole new field of study. Could there be more of these objects out there drifting silently through the cosmos? And if so, what secrets might they hold about the origins of our galaxy or even life itself? As we continue to scan the skies for more interstellar visitors, Oumuamua serves as a tantalizing glimpse into the vast and mysterious universe that surrounds us. It's a cosmic messenger, challenging us to rethink what we know about the cosmos and inspiring us to keep searching for answers. But Oumuamua isn't the only strange object out there. In the depths of space, there are other phenomena that defy explanation, waiting to be uncovered. Deep within the fabric of the universe lies a gravitational force so powerful it's pulling entire galaxies, including our own Milky Way, toward it at incredible speeds. Known as the Great Attractor, this colossal anomaly is one of the most baffling mysteries in cosmology. Imagine a cosmic tug-of-war with galaxies racing toward an unseen force at over 600 miles per second. But here's the catch: we can't see what's pulling us. The Great Attractor lies in a region of space obscured by the dense plane of our galaxy, where stars, gas, and dust block our view. It's like trying to find a lighthouse through a thick, impenetrable fog. Discovered in the 1970s, the Great Attractor sits about 250 million light-years away in the direction of the constellation Centaurus. Its gravitational influence is so immense that it's drawing in thousands of galaxies, including those in the local group which contains our Milky Way. But what exactly is it? Scientists believe it could be a massive concentration of dark matter, an enormous cluster of galaxies, or even something more exotic. The problem is, with so much of it hidden behind the Milky Way's plane, we're left with more questions than answers. To complicate matters further, the Great Attractor isn't the only gravitational anomaly in the universe. Beyond it lies an even larger structure called the Shapley supercluster, which might be amplifying its pull. Together, these forces are reshaping our understanding of cosmic motion, revealing a universe far more dynamic and interconnected than we once imagined. The Great Attractor reminds us that even the most fundamental forces of nature can still hold profound secrets waiting to be uncovered. As we grapple with the mysteries of this gravitational giant, it's worth noting that the universe is filled with other strange structures that defy our expectations. From vast cosmic voids to intricate filaments of galaxies, the cosmos is a tapestry of wonder and enigma. And speaking of strange structures, let's turn our attention to another mind-bending phenomenon, one that challenges our very understanding of how the universe is organized. Now, let's journey to the very edge of what we can observe in the universe, to a structure so unimaginably vast that it challenges our understanding of cosmic scale itself. Meet the Hercules-Corona Borealis Great Wall, the largest known structure in the observable universe, stretching an astonishing 10 billion light-years across. this colossal filament of galaxies is so enormous that it seems to defy the very principles of how the cosmos is supposed to work. To put that into perspective, if you were to travel at the speed of light, it would take you 10 billion years just to cross from one end to the other. And yet, this titanic structure exists, bending our minds and theories alike. Discovered in 2013 by mapping the distribution of gamma-ray bursts, intense flashes of light that mark the deaths of massive stars, the Hercules-Corona Borealis Great Wall is a cosmic behemoth. It's not just a random cluster of galaxies, but a carefully woven tapestry of galaxy clusters, gas, and dark matter, forming a filamentary structure that spans a significant portion of the observable universe. But here's the problem. According to our current understanding of cosmology, structures this large shouldn't exist. The Big Bang theory suggests that the universe in its early stages was remarkably uniform. Over time, gravity pulled matter together to form galaxies, clusters, and filaments. But the scale of this great wall is so extreme that it pushes the limits of what we thought was possible. This discovery has forced scientists to rethink some of their assumptions. Could our understanding of the Big Bang be incomplete, or is there something fundamental we're missing about how matter is distributed on such a grand scale? Some researchers have even proposed that the Hercules-Corona Borealis Great Wall might hint at the existence of other, even larger structures so vast that they might be beyond our current ability to detect. It's a humbling reminder that, even with all our advanced technology, the universe still holds secrets that challenge our most fundamental theories, but the implications go deeper. If structures like this are more common than we thought, it could reshape our understanding of the universe's evolution. It might mean that the cosmos is far more complex and interconnected than we ever imagined, with patterns and structures that stretch across unimaginable distances. The Hercules-Corona Borealis Great Wall isn't just a curiosity, it's a cosmic puzzle that invites us to question what we think we know about the universe. As we grapple with the enormity of this structure, it's worth noting that the universe is full of contrasts. While some regions are densely packed with galaxies, others are eerily empty, vast cosmic voids that seem to defy logic in their own way. And that brings us to our next mystery. Now, let's shift our focus to one of the most hauntingly empty places in the universe, a region so vast and desolate that it's been nicknamed the Great Nothing. This is the Boötes Void, a cosmic void stretching an astonishing 330 million light-years across. To put that into perspective, if you were to place our Milky Way galaxy in the center of this void, the nearest galaxy would be so far away that it would feel like being stranded on an island in the middle of an endless, starless ocean. This void isn't just big, it's baffling, and it challenges our understanding of how the universe is structured. When astronomers first discovered the Boötes Void in the 1980s, they were stunned by its sheer emptiness. While most regions of space are filled with galaxies, clusters, and filaments of matter, this void contains only a handful of galaxies scattered across its immense expanse. It's as if someone carved out a gigantic chunk of the cosmos and left behind a ghostly echo of what was once there. But how could such a vast region of space end up so empty? The answer lies in the complex dance of gravity, dark energy, and the early universe. One theory suggests that the Boötes Void formed as a result of smaller voids merging over billions of years, creating a single, colossal empty space. Another idea points to the influence of dark energy, the mysterious force driving the accelerated expansion of the universe. As dark energy pushes galaxies apart, it could leave behind these vast, empty regions. But even with these explanations, the Boötes Void remains a mystery. Why is it so much larger and emptier than other voids, and what does its existence tell us about the universe's structure on the largest scales? The Boötes Void is more than just a curiosity, it's a window into the fundamental forces shaping the cosmos. It reminds us that the universe isn't just a random scattering of galaxies, but a carefully balanced network of dense clusters and empty voids. And while this great nothing might seem like a cosmic anomaly, it's actually part of a much larger pattern. Voids like this one are thought to play a crucial role in the universe's evolution, acting as the negative spaces that define the intricate web of matter we see around us. But the universe isn't just about emptiness, it's also filled with sudden, explosive events that light up the darkness. And that brings us to our next mystery: strange cosmic explosions that defy explanation and leave scientists scrambling for answers. Now, let's turn our attention to one of the most explosive and awe-inspiring phenomena in the universe: gamma-ray bursts, or GRB. These are the most powerful explosions known to science, capable of releasing more energy in a few seconds than our Sun will emit over its entire 10 billion-year lifespan. To put that into perspective, imagine the energy of a billion suns concentrated into a single, blinding flash of light. It's a staggering display of cosmic power, and yet despite their intensity, gamma-ray bursts remain one of the most enigmatic events in the cosmos. So, what exactly causes these incredible bursts of energy? The answer lies in some of the most violent and dramatic events in the universe. One common source is the collapse of a massive star at the end of its life. When a star many times more massive than our Sun exhausts its fuel, its core collapses under its own gravity, triggering a supernova. In some cases, this collapse creates a black hole, and as the star's outer layers are pulled inward, they form a spinning disk of superheated material. This disk generates powerful jets of energy that shoot out from the poles at nearly the speed of light. If one of these jets happens to be pointed in our direction, we see it as a gamma-ray burst, a brief but dazzling flash of high-energy light. But collapsing stars aren't the only source of GRBs. Another type, known as short gamma-ray bursts, is thought to originate from the collision of two neutron stars. These ultra-dense remnants of dead stars, each about the size of a city but with the mass of a sun, can spiral toward each other over millions of years until they finally merge in a cataclysmic explosion. The collision releases a burst of gamma rays along with gravitational waves that ripple through the fabric of space-time. In fact, it was the detection of gravitational waves in 2017 that confirmed this theory, marking a groundbreaking moment in astrophysics. Despite these discoveries, gamma-ray bursts are far from fully understood. For one thing, they're incredibly rare. Most occur in distant galaxies, billions of light years away, making them difficult to study in detail. And while we've identified some of the events that can trigger GRBs, the exact mechanisms behind their formation and energy release remain unclear. Why do some collapsing stars produce gamma-ray bursts while others don't? What happens in the moments immediately following a neutron-star merger? These are questions that continue to challenge scientists, driving them to develop new tools and techniques to study these fleeting cosmic events. What makes gamma-ray bursts so fascinating is not just their incredible power, but also the clues they hold about the universe. Because they occur so far away, they act as cosmic beacons, allowing us to peer into the distant reaches of space and time. They've helped us map the distribution of matter in the universe, test the limits of Einstein's theory of relativity, and even shed light on the origins of heavy elements like gold and platinum. In many ways, these explosive events are more than just mysteries, they're windows into the fundamental processes that shape our cosmos. As we continue to unravel the secrets of gamma-ray bursts, they remind us of the universe's capacity for both destruction and creation. These bursts are not just moments of chaos, but also catalysts for new beginnings, seeding the cosmos with the building blocks of stars, planets, and even life itself. And while we may never fully understand them, they inspire us to keep looking upward, searching for answers in the vast, energetic tapestry of the universe. But gamma-ray bursts aren't the only cosmic events that leave us in awe. From the depths of space to the heart of our own galaxy, there are other phenomena that defy explanation and challenge our understanding of the cosmos. Let's explore another one of these mysteries next. Now, let's dive into one of the most profound mysteries of the cosmos, a mystery so vast that it makes up nearly 95% of everything in the universe. Yet, despite its overwhelming presence, we can't see it, touch it, or even directly detect it. I'm talking about dark matter and dark energy, the invisible forces that shape the very fabric of our universe. These elusive entities are the ultimate cosmic enigmas, and understanding them could unlock the secrets of everything from the birth of galaxies to the ultimate fate of the cosmos. Dark matter was first proposed in the 1930s, when astronomers noticed that galaxies were spinning far faster than they should based on the visible matter they contained. Without some unseen source of gravity holding them together, these galaxies would simply fly apart. Enter dark matter, a mysterious substance that doesn't emit, absorb, or reflect light, yet exerts a gravitational pull strong enough to bind entire galaxies together. It's like the invisible scaffolding of the universe holding everything in place, but despite decades of research, we still don't know what dark matter is made of. Is it a new kind of particle, a hidden dimension, or something even more exotic? The search for answers continues with experiments deep underground, in particle colliders, and even in space. Then there's dark energy, an even more baffling force. In the late 1990s, astronomers made a startling discovery. The universe isn't just expanding, it's accelerating. Something is pushing galaxies apart faster and faster, and that something is dark energy. Unlike dark matter, which pulls things together, dark energy seems to be doing the opposite, stretching the fabric of spacetime itself. It's as if the universe has a hidden engine, driving its expansion in ways we can't yet explain. Some theories suggest dark energy is a property of space itself, while others propose it's tied to unknown fields or particles. Whatever it is, it's reshaping our understanding of the cosmos on the grandest scale. Together, dark matter and dark energy make up the vast majority of the universe's content, yet they remain almost entirely hidden from us. They're a reminder of how much we still have to learn about the forces that govern existence. But while these invisible giants dominate the cosmos, even the visible parts of the universe hold their share of mysteries. Take, for example, the strange and unexpected behaviors of planets both within our solar system and beyond. That's where our journey takes us next. Let's now venture into the shadowy realm of rogue planets, worlds that drift through the cold, dark expanse of space without the warmth or light of a star to call home. These lonely wanderers, also known as free-floating or orphan planets, are some of the most enigmatic objects in the universe. Unlike Earth, which orbits the Sun, or even exoplanets that circle distant stars, rogue planets are untethered, traveling through the cosmic void on their own. They're like celestial nomads adrift in an endless sea of darkness. The existence of rogue planets challenges what we thought we knew about how planets form. Most planetary systems, including our own, are born from swirling disks of gas and dust around young stars. Over time, this material clumps together, forming planets that settle into stable orbits. But rogue planets seem to defy this process. How do they end up alone, cut off from their stellar parents? One theory suggests they were once part of a solar system, but were violently ejected, perhaps by the gravitational tug of war between larger planets. Another idea is that they formed on their own, directly from collapsing clouds of gas and dust, like stars, but without enough mass to ignite nuclear fusion. Whatever their origins, these planets are a reminder that the universe is far more dynamic and chaotic. than we often imagine. What's truly fascinating about rogue planets is how they manage to survive in such extreme conditions. Without a star to warm them, their surfaces are likely frozen wastelands, with temperatures plunging to hundreds of degrees below zero. Yet, some scientists believe that beneath their icy exteriors, these planets might harbor hidden oceans, kept liquid by internal heat from radioactive decay or tidal forces. This raises the tantalizing possibility that rogue planets could host life, even in the absence of starlight. Imagine microbial organisms thriving in the depths of a dark subsurface ocean, completely isolated from the rest of the universe. It's a scenario that pushes the boundaries of what we consider habitable. Detecting rogue planets is no easy task. Since they don't reflect light from a star, they're incredibly dim and difficult to spot. Most are discovered through a technique called gravitational microlensing, where their gravity briefly bends and magnifies the light of a background star, creating a telltale flash. These fleeting glimpses are often the only clues we have to their existence. But with advances in technology, astronomers are finding more of these elusive worlds, revealing a population of rogue planets that may outnumber the stars in our galaxy. Rogue planets are more than just cosmic curiosities. They're a window into the chaotic and unpredictable nature of planetary systems. They remind us that not all worlds are bound to stars and that the universe is full of surprises waiting to be uncovered. And while these solitary wanderers drift through the darkness, there are other celestial objects closer to home that are just as mysterious. Take, for example, the strange and enigmatic moons that orbit some of our solar system's planets, each with its own set of peculiarities and secrets. One of the most peculiar objects in our solar system isn't a planet or a distant star. It's a small, potato-shaped moon orbiting Saturn. Meet Hyperion, a celestial oddball with a surface so strange it looks like it's been pummeled by cosmic fists. This moon, measuring just over 200 kilometers across, is covered in deep, irregular craters that give it a sponge-like texture. But Hyperion's bizarre appearance is only the beginning of its mysteries. What makes this moon truly unique is its chaotic rotation. Unlike most moons, which spin predictably on their axes, Hyperion tumbles through space in a seemingly random pattern, flipping and wobbling as it orbits Saturn. It's as if the moon has a mind of its own, defying the orderly laws of celestial mechanics. So, what could have caused Hyperion to become such a cosmic anomaly? One theory points to its porous structure. Scientists believe that Hyperion is made up of a loosely packed mix of ice and rock, giving it a low density and a fragile, almost fragile-like composition. This spongy texture might explain why the moon's surface is riddled with deep craters. Impacts from asteroids or comets could have compressed its surface without ejecting much material, creating those distinctive honeycomb-like pits. But this delicate structure also raises questions about how Hyperion has survived billions of years without being torn apart by Saturn's gravitational forces. Another mystery lies in Hyperion's chaotic rotation. Most moons are tidally locked, meaning one side always faces their parent planet. But Hyperion's irregular shape and uneven distribution of mass make it impossible for Saturn's gravity to stabilize its spin. Instead, the moon tumbles erratically, with its axis of rotation shifting unpredictably over time. This chaotic behavior is so unusual that Hyperion is one of the only known objects in the solar system to exhibit it. Some scientists speculate that a massive collision in the moon's distant past could have set it on this unstable path, but the exact cause remains unknown. Hyperion isn't just a curiosity, it's a testament to the strange and unpredictable nature of the cosmos. Its sponge-like surface and chaotic spin challenge our understanding of how moons form and evolve, reminding us that even within our own solar system, there are still mysteries waiting to be unraveled. And while Hyperion's peculiarities are fascinating, they're just one piece of a much larger puzzle. Saturn's rings, for example, hold their own share of enigmas with structures and patterns that defy explanation. Let's turn our attention to those next. Now, let's journey to Saturn, the ringed giant of our solar system, where a bizarre and mesmerizing feature has captivated astronomers for decades. At its north pole, a colossal hexagon-shaped storm rages, stretching nearly 25,000 kilometers across, wide enough to engulf two Earths side by side. This six-sided jet stream, known as Saturn's hexagon, is a geometric marvel defying the chaotic nature of planetary weather systems. Unlike the swirling storms we see on other planets, this hexagon has maintained its precise shape for over 40 years, making it one of the most enduring and enigmatic features in our solar system. What makes Saturn's hexagon so extraordinary is not just its symmetry but its persistence. Storms on Earth or even Jupiter's Great Red Spot are dynamic, constantly shifting and evolving. Yet, Saturn's hexagon has remained strikingly stable since it was first observed by the Voyager missions in the early 1980s. Its edges are razor-sharp, forming a near-perfect hexagon, while winds inside the storm whip around at speeds of over 300 kilometers per hour. How does such a precise geometric pattern emerge and endure in the turbulent atmosphere of a gas giant? Scientists have proposed several theories to explain this phenomenon. One leading idea suggests that the hexagon is the result of atmospheric waves interacting with Saturn's rotation. Imagine throwing a stone into a pond and watching ripples spread outward. On Saturn, these ripples could be shaped by the planet's rapid spin, creating standing waves that lock into a hexagonal pattern. Another theory points to the influence of deep-rooted jet streams within Saturn's atmosphere, which might organize the storm into this unique shape. Some researchers even speculate that the hexagon could be linked to the planet's magnetic field, adding another layer of complexity to its formation. Yet, despite these theories, the hexagon remains a puzzle. Why doesn't it lose its shape over time? Why doesn't it drift or collapse like other storms? And why does it only exist at Saturn's North Pole, with no similar feature at the South Pole? The answers to these questions could reshape our understanding of planetary atmospheres, revealing new insights into the forces that govern weather on gas giants. Saturn's hexagon isn't just a curiosity, it's a testament to the strange and beautiful complexity of our solar system. Its existence challenges our assumptions about how planetary systems behave, reminding us that even the most familiar objects in the cosmos can still surprise us. And while this six-sided storm continues to baffle scientists, it's far from the only atmospheric mystery out there. From the swirling vortices of Jupiter to the unexplained dark spots on Neptune, the planets of our solar system are brimming with phenomena that defy explanation. Let's explore one of these mysteries next. Now, let's take a closer look at one of the most visually striking and puzzling objects in the cosmos, the Red Rectangle Nebula. Nestled in the constellation Monoceros, about 2,300 light-years from Earth, this nebula stands out not just for its vibrant red hue, but for its bizarre, almost artificial shape. While most nebulae are known for their swirling, chaotic forms, the Red Rectangle is an exception. Its structure is strikingly geometric, with a series of nested rectangles and an X-shaped pattern at its core. It's as if someone sketched a cosmic blueprint and left it floating in space. But how did this peculiar shape come to be, and what forces are at work within it? The Red Rectangle Nebula, officially known as HD 44179, is a protoplanetary nebula, a phase in the life cycle of a dying star. At its heart lies a binary star system, where one star has exhausted its nuclear fuel and is shedding its outer layers into space. This process creates the glowing gas and dust that form the nebula's distinct shape. But why the rectangles? Scientists believe the geometric structure is the result of intense stellar winds and magnetic fields shaping the ejected material into a series of cones. When viewed from Earth, these cones appear stacked, creating the illusion of nested rectangles. It's a cosmic optical illusion, but one that's no less fascinating for it. What makes the red rectangle even more intriguing is its color. The deep red glow comes from a rare type of organic molecule known as polycyclic aromatic hydrocarbons, or PAH, which are excited by ultraviolet light from the central stars. These molecules are thought to be the building blocks of more complex compounds, and their presence in the nebula raises questions about the role such structures might play in the formation of life elsewhere in the universe. Could the red rectangle be a kind of cosmic laboratory, churning out the ingredients for future worlds? It's a tantalizing possibility, and one that continues to captivate astronomers. Despite decades of study, the Red Rectangle Nebula remains shrouded in mystery. Why does it have such a precise geometric shape when other nebulae are so chaotic? What processes are driving its unique structure, and what will happen to it as the central star continues to evolve? These are questions that keep scientists coming back to this enigmatic object, searching for clues to its origins and ultimate fate. The red rectangle is a reminder that even in the vastness of space, nature can produce patterns that seem almost too perfect to be real. But while the red rectangle's geometric beauty is mesmerizing, the universe is also home to phenomena that are anything but orderly. In fact, some of the most dramatic events in the cosmos are the result of chaos-violent collisions that reshape worlds and leave behind a trail of cosmic debris. And that brings us to our next mystery: strange and powerful collisions that defy our expectations and challenge our understanding of how the universe works. Now, let's turn our gaze toward a celestial spectacle that looks more like a work of art than a natural phenomenon: the Antennae galaxies. Located about 45 million light-years away in the constellation Corvus, these two spiral galaxies are locked in a slow-motion cosmic dance, their arms stretched and twisted into a shape that resembles the antennae of an insect. But this isn't just a beautiful sight, it's a glimpse into the chaotic and transformative process of galactic evolution. The Antennae galaxies, formerly known as NGC 4038 and NGC 4039, are in the midst of a collision that began hundreds of millions of years ago. As they spiral closer together, their immense gravitational forces pull stars, gas, and dust into long, sweeping tails that stretch across the void. These tails are what give the galaxies their distinctive antennae appearance, but they're also a testament to the sheer power of galactic interactions. Within these tails, new stars are being born at an astonishing rate, ignited by the compression of gas clouds as the galaxies merge. It's a cosmic firestorm where destruction and creation go hand in hand. What makes this collision so fascinating is what it tells us about the future of galaxies, including our own Milky Way. The Antennae galaxies are a preview of what could happen when our galaxy collides with the nearby Andromeda galaxy in about 4 billion years. While that might sound catastrophic, the process is surprisingly common in the universe. Galaxies often collide, and these interactions are a key driver of their evolution. They reshape structures, trigger bursts of star formation, and even pave the way for the birth of supermassive black holes. In many ways, these collisions are the universe's way of recycling itself, turning chaos into new beginnings. But the Antennae galaxies aren't just a window into the past or future, they're also a cosmic laboratory. By studying them, astronomers can learn how galaxies grow, how stars form in extreme environments, and how dark matter influences these interactions. The collision has created a rich tapestry of phenomena, from massive star clusters to supernova explosions, each offering clues about the forces that shape the universe. And yet, despite all we've learned, the Antennae galaxies remain a reminder of how much we still have to discover. What happens to the supermassive black holes at the centers of these galaxies as they merge? How do the newly formed stars and planets evolve in such a chaotic environment? These are questions that keep scientists coming back to this stunning pair of galaxies. As we marvel at the Antennae galaxies, it's worth noting that the universe is full of other collisions and interactions, each with its own story to tell. From the chaotic birth of stars to the mysterious forces that drive galactic evolution, the cosmos is a dynamic and ever-changing place. And speaking of mysteries, let's shift our focus to another cosmic enigma, one that involves invisible, high-energy particles bombarding our planet from the depths of space. Now, let's turn our attention to a mysterious feature imprinted on the very fabric of the universe, a faint, ancient echo that holds clues to its birth. This is the cosmic microwave background, or CMB, the afterglow of the Big Bang. While the CMB is remarkably uniform, there's one region that stands out like a cosmic sore thumb, a chilling anomaly known as the CMB Cold Spot. Stretching nearly 2 billion light-years across, this unusually cold region defies expectations, sparking debates about what could have caused it and what it might mean for our understanding of the cosmos. The CMB Cold Spot was first detected by the Wilkinson Microwave Anisotropy Probe in the early 2000s and later confirmed by the Planck satellite. Unlike the rest of the CMB, which shows tiny fluctuations in temperature, this spot is significantly colder than its surroundings. At first glance, it might seem like a minor detail, but in the context of the universe's history, it's anything but. The CMB is essentially a snapshot of the universe when it was just 380,000 years old, and any anomalies in it could point to extraordinary events or structures that shaped the cosmos in its infancy. So, what could explain this frigid patch? One leading theory suggests it's the imprint of a massive cosmic void, a region of space where matter is unusually sparse. If such a void existed along the line of sight to the cold spot, it could cause light passing through it to lose energy, creating the illusion of a colder region. This process, known as the integrated Sachs-Wolf effect, is a plausible explanation, but the size of the void required would be astonishingly large even by cosmic standards. Some researchers argue that such a void would be so rare that it challenges our understanding of how matter is distributed in the universe. Another, more speculative theory takes the cold spot into the realm of science fiction. Some scientists have proposed that it could be evidence of a collision between our universe and another parallel universe, a so-called multiverse. According to this idea, the cold spot might be a kind of bruise left behind by a cosmic collision, a remnant of an interaction with another bubble of spacetime. While this idea is highly controversial and lacks direct evidence, it's a tantalizing possibility that pushes the boundaries of cosmology. Despite decades of study, the CMB Cold Spot remains unexplained. It's a reminder that even the most fundamental aspects of the universe can hold profound mysteries. Whether it's a cosmic void, a multiverse collision, or something entirely different, this anomaly challenges us to rethink what we know about the early universe and the forces that shaped it. And as we continue to probe the cosmos, it's discoveries like these that keep us questioning, exploring, and marveling at the vastness of existence. But while the CMB Cold Spot takes us back to the universe's earliest moments, there are other mysteries that bring us closer to home phenomena involving stars that behave in ways we can't yet explain. Let's shift our focus to one such star whose strange flickering has left astronomers utterly baffled. Now, let's turn our attention to one of the most bizarre survivors in the cosmos, stars that refuse to die, even after experiencing one of the most violent events in the universe. These are zombie stars, celestial objects that somehow cheat death by surviving supernova, the explosive deaths of stars. Imagine a star reaching the end of its life, exploding with the energy of 1 billion suns, and yet instead of fading into darkness, it continues to shine. It's as if the universe itself has a sense of irony, creating stars that defy the very rules of their existence. Zombie stars are born from a peculiar twist in the life cycle of massive stars. Normally, when a star exhausts its nuclear fuel, its core collapses, triggering a supernova that obliterates the star and leaves behind a neutron star or black hole. But in some rare cases, the explosion isn't strong enough to completely destroy the star. Instead, the outer layers are blasted away while the core survives, reigniting and continuing to burn. The result is a star that's been through hell and back, yet still glows defiantly in the night sky. One of the most famous examples is the star LP40-145, which survived a supernova and now shines brighter than ever, challenging everything we thought we knew about stellar death. What makes these stars so fascinating is how they force us to rethink the life cycles of stars. For decades, astronomers believed that supernovae were the final act in a star's life, a definitive endpoint. But zombie stars suggest that the universe is far more unpredictable than we imagined. They raise questions about the conditions needed for a star to survive such a cataclysmic event. Is it a matter of mass, composition, or something else entirely? Each zombie star we discover adds another layer to this cosmic puzzle, pushing us to refine our models of stellar evolution. But the intrigue doesn't stop there. Zombie stars also hint at the possibility of other strange stellar survivors out there. Some scientists speculate that these stars might even be the precursors to exotic objects like magnetars or hypervelocity stars, which are flung across the galaxy at incredible speeds. Others wonder if zombie stars could help explain some of the unusual supernovae we've observed, which don't quite fit the standard models. In a way, these stars are like cosmic rebels, breaking the rules and forcing us to rewrite the textbooks. As we continue to study these resilient stars, they remind us that the universe is full of surprises. Just when we think we've figured out how things work, nature throws us a curveball, challenging our assumptions and sparking new questions. And while zombie stars are fascinating in their own right, they're just one piece of the larger puzzle of stellar mysteries, from stars that vanish without a trace to those that flicker in ways we can't explain. The cosmos is brimming with phenomena that defy our understanding. Let's dive into another one of these stellar enigmas next. Now, let's explore a planet that sounds like it belongs in a science fiction novel, a world so extraordinary that it's been nicknamed the Diamond Planet. Officially known as 55 Cancri, this exoplanet orbits a star about 40 light-years from Earth in the constellation Cancer. But what makes this planet truly remarkable is its composition. Scientists believe it's made largely of diamond and graphite, making it one of the most valuable objects in the galaxy, at least in theory. The Diamond Planet is a super-Earth, a type of planet larger than Earth but smaller than gas giants like Neptune. What sets it apart is its extreme density and composition. Researchers estimate that about 1/3 of its mass could be pure diamond, formed under immense pressure and heat. To put it simply, this planet is like a gigantic cosmic gemstone shimmering in the void. But how did such a planet come to exist? The answer lies in its star system. 55 Cancri orbits very close to its host star, completing a full orbit in just 18 hours. This proximity means the planet is subjected to scorching temperatures, reaching over 2000 degrees Celsius. Under these conditions, carbon-rich materials in its interior could crystallize into diamond, creating a world unlike anything in our solar system. This planet's existence challenges our understanding of planetary formation. Most planets, including Earth, are composed of silicate rocks and metals, with carbon playing a minor role. But 55 Cancri suggests that under the right conditions, carbon can dominate a planet's composition, leading to exotic worlds like this one. It's a reminder that the universe is far more diverse than we often imagine, capable of creating planets that defy our expectations. And while the idea of a diamond planet is undeniably fascinating, it also raises questions. Could such a planet ever be mined? Theoretically, yes, but with its extreme heat and hostile environment, it's more of a cosmic curiosity than a practical resource. As we marvel at the diamond planet, it's worth noting that the universe is full of other treasures, not all of which are as solid or tangible. Some of the most intriguing cosmic phenomena involve particles so small and elusive that they're almost impossible to detect. And that brings us to our next mystery, the strange and mysterious cosmic rays that bombard our planet from the depths of space. Now, let's shift our focus from glittering diamond planets to something far more elusive and mysterious, a particle so energetic that it left scientists speechless when it was discovered. Meet the Oumuamua particle, an ultra-high-energy cosmic ray detected in 1991 that shattered our understanding of particle physics. This single particle carried an energy level so staggering that it defies belief. It was traveling at nearly the speed of light, packing as much punch as a baseball moving at 60 miles per hour, all condensed into a single subatomic speck. To put it simply, this particle was a cosmic powerhouse, and its discovery sent shockwaves through the scientific community. The Oumuamua particle was detected by the Fly's Eye Cosmic Ray Detector in Utah, a facility designed to catch fleeting glimpses of cosmic rays, high-energy particles that rain down on Earth from deep space. But this particular particle was unlike anything ever recorded. Its energy level was estimated to be around 50 joules, equivalent to dropping a textbook from waist height. That might not sound like much, but for a single particle, it's an astronomical amount of energy, millions of times more powerful than anything produced in human-made particle accelerators like the Large Hadron Collider. The sheer magnitude of this energy left researchers scrambling for explanations. Where could such a particle have come from, and what cosmic event could have unleashed it? Theories about the Oumuamua particle's origins range from the plausible to the wildly speculative. Some scientists believe it could have been accelerated by the intense magnetic fields of a supermassive black hole, which are capable of launching particles across the universe at mind-boggling speeds. Others suggest it might have originated from a cataclysmic event like a hypernova or the collision of two neutron stars, events so violent they can generate energies far beyond anything we've observed. But even these explanations fall short of fully accounting for the particle's incredible speed and energy. The truth is, we simply don't know what could have created such a phenomenon, and that's what makes it so fascinating. What's even more perplexing is that the Oumuamua particle shouldn't exist at all, at least according to our current understanding of physics. The universe is filled with a faint glow of microwave radiation known as the cosmic microwave background, which permeates all of space. As particles travel through this radiation, they lose energy over time, a process known as the GZK cutoff. This means that ultra-high-energy particles like the Oumuamua particle should be impossible to detect from great distances, yet here we are with evidence that defies this limit. It's as if the universe is sending us a cryptic message, challenging us to rethink the very laws that govern it. The Oumuamua particle isn't just a scientific curiosity, it's a reminder of how much we still have to learn about the cosmos. It raises questions about the nature of energy, the limits of particle physics, and the extraordinary events that shape our universe. And while we may never fully understand its origins, it continues to inspire researchers to push the boundaries of what we know, searching for answers in the vast, energetic tapestry of space. As we ponder the mysteries of this enigmatic particle, let's turn our attention to another cosmic puzzle, one that involves strange alignments in the universe, where stars, galaxies, and even larger structures seem to fall into place in ways that defy chance. What could be causing these mysterious patterns, and what do they reveal about the hidden forces shaping the cosmos? Let's explore this next. Now, let's turn to one of the most mind-boggling structures in the universe, a colossal assembly of galaxies so vast that it stretches the limits of what we thought was possible. This is the Great Wall of Galaxies, a gargantuan filament of galaxies, gas, and dark matter that spans an astonishing 500 million light-years across. To put that into perspective, if you could travel at the speed of light, it would take you 500 million years just to cross from one end to the other. This monumental structure is one of the largest known formations in the observable universe, and its existence challenges some of our most fundamental ideas about how the cosmos evolved. The Great Wall was first discovered in the 1980s when astronomers began mapping the distribution of galaxies across the universe. What they found was astonishing. Galaxies weren't scattered randomly through space but clustered into immense web-like structures with vast voids separating them. The Great Wall is one of the most prominent of these structures, a cosmic superhighway of galaxies that defies expectations. According to the Big Bang theory, the universe started as a hot, dense soup of matter and energy, which, as it expanded, should have distributed matter fairly evenly. Yet structures like the Great Wall suggest that the universe is far more lumpy and uneven than the theory predicts. How could something so enormous form in the time since the Big Bang? It's a question that keeps cosmologists up at night. One leading theory is that the Great Wall is the result of tiny fluctuations in the early universe, ripples in the fabric of space-time that grew over billions of years, pulled together by gravity. These ripples, imprinted in the cosmic microwave background, might have acted as seeds for the formation of galaxies and larger structures. But even this explanation struggles to account for the sheer scale of the Great Wall. Some scientists have proposed that dark energy, the mysterious force driving the universe's accelerated expansion, might have played a role in shaping these structures. Others suggest that our understanding of gravity on cosmic scales might need revision. Whatever the answer, the Great Wall is a stark reminder that the universe is far more complex and far stranger than we once thought. What makes the Great Wall even more fascinating is what it tells us about the universe's structure. It's not just a random cluster of galaxies, but part of a larger cosmic web, a network of filaments and voids that stretches across the cosmos. These structures are thought to be the scaffolding of the universe, the framework on which galaxies, stars, and even life itself are built. By studying the Great Wall, astronomers hope to uncover clues about how the universe evolved, how dark matter and dark energy shaped its growth, and what secrets might be hidden in the vast spaces between galaxies. As we marvel at the sheer scale of this galactic giant, it's worth noting that the universe is full of other mysteries, some of which aren't about light or structures but about the absence of them. And that brings us to our next enigma, strange cosmic shadows that seem to blot out light in ways we can't yet explain. Now, let's explore a phenomenon that seems to defy the very laws of the cosmos, a mysterious pull on galaxy clusters so strange it's been dubbed the dark flow. Imagine the universe as a vast ocean, and instead of drifting aimlessly, entire galaxies are being swept along by an unseen current. This isn't just a poetic metaphor, it's a real, measurable phenomenon that has left scientists scratching their heads. The dark flow describes the peculiar motion of galaxy clusters, which appear to be moving in unison toward a specific region of space at incredible speeds. But here's the catch, there's nothing in that direction, no massive structure, no supercluster, no obvious gravitational source. So what could be pulling them? The discovery of the dark flow dates back to 2008, when astronomers studying the cosmic microwave background, the faint afterglow of the Big Bang, noticed something unusual. They found that hundreds of galaxy clusters were moving in the same direction at speeds of up to 1,000 kilometers per second. This motion couldn't be explained by the known distribution of matter in the universe. It was as if an invisible hand were tugging these clusters toward a point beyond the edge of the observable universe. But how could something outside our cosmic horizon, the limit of what we can see, exert such a profound influence? One of the most intriguing theories suggests that the dark flow might be evidence of something beyond our universe, a neighboring cosmos exerting its gravitational pull. According to this idea, our universe might be just one of many in a vast multiverse, and the dark flow could be the gravitational imprint of another bubble of space-time. It's a mind-bending concept, but one that has gained traction among some cosmologists. Another possibility is that the dark flow is tied to the early universe, perhaps reflecting remnants of an ancient pre-Big Bang structure that still shapes the motion of galaxy clusters today. While these ideas remain speculative, they highlight just how little we understand about the forces at work in the cosmos. What makes the dark flow so fascinating is that it challenges our understanding of the universe on the grandest scale. It raises questions about the nature of gravity, the shape of space-time, and even the possibility of other universes beyond our own. And while some scientists remain skeptical, arguing that the dark flow could be a statistical anomaly or an artifact of measurement, the evidence continues to mount, making it one of the most compelling mysteries in modern cosmology. As we grapple with the enigma of the dark flow, it's worth noting that the universe is full of other unexplained motions, galaxies spinning faster than they should, stars hurtling through space at impossible speeds, and even entire clusters of galaxies moving in ways that defy our models. Each of these phenomena reminds us that the cosmos is far more dynamic and mysterious than we often imagine. And speaking of mysterious motions, let's shift our focus to another cosmic puzzle, one that involves the strange and unexpected ways light behaves in the depths of space. Now, let's zoom in on one of the most mysterious structures lurking in our own galactic backyard, the Fermi Bubbles. These colossal gamma-ray emitting structures stretch an astonishing 25,000 light-years above and below the center of the Milky Way, forming a gigantic hourglass shape that dwarfs our entire galaxy. Discovered in 2010 by NASA Fermi Gamma-Ray Space Telescope, these bubbles are a cosmic enigma, radiating high-energy gamma rays that defy easy explanation. How did these massive structures form, and what could possibly generate such immense energy at the heart of our galaxy? The origins of the Fermi bubbles remain hotly debated, but one leading theory points to the supermassive black hole at the center of the Milky Way, known as Sagittarius A star. This black hole, with a mass 4 million times that of our Sun, is thought to have undergone a period of intense activity in the past, spewing out jets of energy and matter that inflated these massive bubbles. Another possibility is that they were created by a burst of star formation in the galactic center, with countless supernovae exploding in quick succession and releasing enough energy to carve out these structures. Either way, the Fermi bubbles are a striking reminder of the dynamic and sometimes violent processes at work in our galaxy. What makes these bubbles so intriguing is not just their size but their composition. The gamma rays they emit suggest the presence of high-energy particles, accelerated to near-light speeds by some unknown mechanism. This has led scientists to wonder if the bubbles could be a kind of cosmic particle accelerator, powered by the immense forces at the galactic center. But even with these theories, the Fermi bubbles remain a puzzle. Why do they have such sharp edges? What caused the black hole or star formation to activate so dramatically? And how long have these structures been there, quietly glowing in gamma rays? The Fermi bubbles are more than just a galactic curiosity. They're a window into the hidden forces shaping our galaxy. They challenge our understanding of how supermassive black holes and star formation influence their surroundings, and they remind us that even our own Milky Way holds secrets waiting to be uncovered. As we continue to study these colossal structures, they offer a glimpse into the energetic processes that drive galactic evolution. And while the Fermi Bubbles captivate our imagination, they're far from the only mysterious signals emanating from the cosmos. In fact, the universe is filled with strange, unexplained signals that seem to defy logic, like the ones we'll explore next. Now, let's dive into one of the most perplexing mysteries in the history of space exploration, the Pioneer Anomaly. Back in the 1970s, NASA launched the Pioneer 10 and 11 spacecraft on missions to explore the outer solar system. These robotic pioneers were trailblazers, sending back invaluable data about Jupiter, Saturn, and beyond. But as they ventured farther into the void, something strange happened. Both spacecraft began to slow down ever so slightly, deviating from their expected trajectories. This unexpected deceleration, now known as the Pioneer Anomaly, became a puzzle that has baffled scientists for decades. At first, the anomaly seemed minor, just a tiny, unexplained force acting on the spacecraft. But in the precise world of physics, even the smallest discrepancies can point to something profound. Over time, the deceleration added up, causing the spacecraft to drift off course by hundreds of thousands of kilometers. What could be causing this? One of the leading explanations involves thermal radiation. As the spacecraft traveled through space, heat from their radioactive power sources could have been emitted unevenly, creating a tiny but measurable push in the opposite direction. This theory seemed plausible, but detailed studies revealed that thermal radiation alone couldn't fully account for the anomaly. This led scientists to consider more exotic possibilities. Could the Pioneer Anomaly be evidence of new physics, a hint that our understanding of gravity or space-time is incomplete? Some researchers speculated that it might be connected to dark matter or even modifications to Einstein's theory of general relativity. These ideas, while intriguing, remain unproven. What's clear is that the Pioneer Anomaly challenges our understanding of how objects move through space, especially in the distant reaches of the solar system where the gravitational influence of the Sun grows faint. Despite years of analysis, the mystery of the Pioneer Anomaly remains unsolved. It's a humbling reminder that even our most advanced technology and theories can't always explain the behavior of the cosmos. The anomaly also highlights the importance of precision in space exploration. Every tiny deviation, every unexplained force could be a clue to something much larger, a hidden law of nature waiting to be uncovered. And while the Pioneer spacecraft have long since gone silent, their legacy lives on, inspiring new missions and experiments designed to unravel the secrets of the universe. But while the Pioneer Anomaly deals with the subtle forces acting on spacecraft, the cosmos is also home to explosive events so powerful they can outshine entire galaxies. These are the mysterious cosmic explosions that light up the darkness, leaving astronomers scrambling to understand their origins. Let's turn our attention to one of these dramatic phenomena next. Now let's journey back to June 30th, 1908, to a remote corner of Siberia where one of the most powerful explosions in recorded history occurred. An event so massive it flattened over 2,000 square kilometers of forest, yet left no crater behind. This is the Tunguska Event, a cosmic mystery that has puzzled scientists for over a century. Early that morning, eyewitnesses described a blinding flash of light, followed by a shockwave so intense it knocked people off their feet hundreds of kilometers away. The sound of the explosion was heard as far as 1,000 kilometers away, and the night skies across Europe and Asia glowed eerily for days. Yet, when researchers finally reached the site years later, they found no trace of a crater, no fragments of a meteorite, just a vast expanse of scorched and flattened trees. What could have caused such devastation? Theories about the Tunguska event range from the plausible to the wildly speculative. The most widely accepted explanation is that it was caused by a meteoroid or comet exploding in the atmosphere, releasing energy equivalent to 10 to 15 megatons of TNT, hundreds of times more powerful than the atomic bomb dropped on Hiroshima. This kind of airburst could explain the lack of a crater, as the object would have disintegrated before reaching the ground. But here's the catch: no fragments of the object have ever been found, leaving scientists to wonder if it was made of something unusually volatile, like a fragile comet composed mostly of ice and dust. Then there are the more exotic theories. Some have suggested that the Tunguska event was caused by a tiny black hole passing through Earth, releasing energy as it exited the planet. Others have proposed it might have been an antimatter explosion or even the result of a malfunctioning alien spacecraft. While these ideas are far less likely, they highlight just how baffling this event remains. Without conclusive evidence, the Tunguska event continues to be a source of fascination and debate, a reminder that even our own planet can be the stage for cosmic mysteries. What makes the Tunguska event so compelling is not just the scale of the explosion, but the questions it raises about our vulnerability to similar events in the future. Could it happen again? The answer is yes. In fact, smaller airbursts have occurred since, like the Chelyabinsk meteor in 2013, which injured over 1,000 people. These events remind us that space isn't as empty as it seems, and that Earth is constantly navigating a cosmic shooting gallery. The Tunguska event is a stark warning of the potential dangers lurking in the skies above. As we reflect on this enigmatic explosion, let's turn our attention to another cosmic mystery, one that involves not destruction, but strange and unexpected alignments in the universe. From the way galaxies cluster together to the peculiar motions of celestial bodies, these patterns challenge our understanding of how the cosmos is organized. What could be causing these mysterious alignments, and what do they reveal about the hidden forces shaping the universe? Let's explore this next. Now, let's venture to the outer reaches of our solar system, where the familiar gives way to the mysterious. Beyond Neptune lies the Kuiper Belt, a vast ring of icy bodies and dwarf planets that marks the boundary of our cosmic neighborhood. But at the very edge of this belt, something strange happens: a sudden and dramatic drop-off in the number of objects. This boundary, known as the Kuiper Cliff, is one of the most puzzling features in our solar system. It's as if an invisible line has been drawn, beyond which the icy debris simply vanishes. What could cause such a sharp and unexpected boundary, and what does it tell us about the formation and evolution of our solar system? The Kuiper Cliff was first noticed in the early 21st century as astronomers began mapping the distribution of objects in the Kuiper Belt. They expected to find a gradual decrease in the number of objects as they moved farther from the Sun. But instead, they found a sharp cutoff at about 50 astronomical units from the Sun, about 50 times the distance between Earth and the Sun. Beyond this point, the number of objects drops off almost completely, leaving a vast and eerily empty region. This abrupt boundary challenges our understanding of how the solar system formed. If the Kuiper Belt is a remnant of the primordial disk of material that once surrounded the young Sun, why does it end so suddenly? What could have caused this cosmic cliff? One of the leading theories suggests that the Kuiper Cliff might be the result of an unseen planet lurking in the outer solar system. This hypothetical world, often referred to as Planet 9, could have swept up or ejected objects beyond the cliff through its gravitational influence. While Planet 9 remains undiscovered, its existence could explain not only the Kuiper Cliff, but also the peculiar orbits of some distant objects in the Kuiper Belt. Another possibility is that the cliff marks the edge of the Sun's gravitational influence, where the pull of other stars in the Milky Way begins to dominate. This could have disrupted the formation of objects beyond this point, leaving a stark boundary. But the Kuiper Cliff isn't just a scientific curiosity, it's a clue to the history of our solar system. It suggests that the outer reaches of the Kuiper belt were shaped by forces we're only beginning to understand. Some researchers believe the cliff could be a fossilized record of the early solar system, preserving the effects of ancient gravitational interactions or even the migration of Neptune billions of years ago. Others think it might hint at the presence of other, smaller objects or structures that we haven't yet detected. Whatever the explanation, the Kuiper Cliff reminds us that the solar system is far more dynamic and complex than we often imagine. As we stand at the edge of the Kuiper belt, gazing into the void beyond, it's worth reflecting on what this mysterious boundary tells us about the universe. The Kuiper Cliff is just one of many cosmic puzzles we've explored today, from the enigmatic WOW signal to the colossal Hercules-Corona Borealis Great Wall. Each of these phenomena challenges our understanding of the cosmos, pushing us to rethink what we know and inspiring us to keep searching for answers. Together, they paint a picture of a universe that's vast, mysterious, and endlessly surprising. And as we wrap up this journey through the unknown, one thing is clear: the cosmos still holds countless secrets waiting to be uncovered by the curious minds of tomorrow. As we've journeyed through these 25 unusual phenomena, one thing has become abundantly clear: the universe is stranger and more wondrous than we could ever imagine. From the fleeting whispers of the WOW signal to the colossal structures like the Hercules-Corona Borealis Great Wall, each mystery challenges our understanding of the cosmos in profound ways. These enigmas remind us that, despite centuries of observation and decades of technological advancement, we've only just begun to scratch the surface of what the universe has to reveal. Take a moment to reflect on the sheer diversity of these phenomena. We've explored stars that refuse to die, planets made of diamond, and cosmic explosions that outshine entire galaxies. We've marveled at the precision of Saturn's hexagonal storm and puzzled over the invisible pull of the dark flow. Each discovery pushes the boundaries of science, forcing us to rethink our assumptions about gravity, matter, and the very fabric of reality. These aren't just curiosities, they're clues, pointing us toward deeper truths about how the universe works and our place within it. But what makes these mysteries so compelling isn't just their strangeness, it's what they represent. They're a testament to the boundless creativity of the cosmos, a reminder that the universe is always ready to surprise us. They also highlight the importance of curiosity and exploration. Every unexplained signal, every unusual alignment, every cosmic anomaly is an invitation to ask questions, to probe deeper, and to keep searching for answers. The pursuit of these mysteries isn't just about satisfying our curiosity, it's about expanding the horizons of human knowledge and understanding. As we wrap up this exploration, let's leave you with a thought from Carl Sagan, who once said, "Somewhere, something incredible is waiting to be known." These words capture the spirit of our journey today. The universe is vast, filled with wonders that defy explanation and possibilities that stretch the limits of our imagination. And while we may not yet have all the answers, that's part of what makes the cosmos so thrilling. Every mystery we solve opens the door to new questions, new discoveries, and new adventures. Before we go, we'd love to hear your thoughts. Which of these phenomena fascinated you the most? Do you have your own theories about what might be causing these cosmic enigmas? Share your ideas in the comments below. We're excited to hear your perspectives. And if you've enjoyed this journey through the mysteries of space, don't forget to subscribe and join us for more cosmic explorations. The universe is full of stories waiting to be told, and we can't wait to uncover them with you. Until next time, keep looking up. The stars have so much more to show us.